Zeal Education Society, redefining excellence.
Hello students, I am Dr. Mahadev Unde, Professor, Zeal College of Engineering and Research, Pune. In the last video lecture, we have learned the current relations, voltage relations and power relations in case of three-phase balanced star connected load. Now in this lecture, we are going to learn how to find the current relation, voltage relation and power relations for a three-phase balanced delta connected inductive load. Now for this, consider the diagram. That is, one is supply system, that is the generating stations, other is the load system, that is the load center. So, and the lines connecting between the generating stations and load centers are known as transmission lines, and current flowing through them is the line currents, and the voltage between them are the line voltages. So let us draw. This is R, this is Y, and this is B. This is three-phase dimmer. So this is R, then this is Y line, and this is B line. Now draw the load impedances. This is for R phase, this is for Y phase, and this is for B phase. So this is three-phase balanced delta connected inductive load. Balanced delta connected inductive load. This is three-phase AC 50 Hz supply. So one is supply system, other is load system. And these lines, we have to show the current flowing through the lines known as line current. So current flowing through the R line is I capital R, current flowing through the Y line is I capital Y, and current flowing through the B line is I capital B. Similarly, the voltage between two lines is known as line voltage, and therefore the voltage between the line R and Y is phi RY. Then voltage between Y and B is phi YB, and finally the voltage between B and R, so it is phi BR. That is the between B and R. Similarly, we have to show the currents. The phase current, the current flowing through the respective phase of a load. This is the R phase of the load, this is Y phase, and this is B phase of the load. So current flowing is I small r, I small y, and this is I small b. And the voltages, see, this is R, this is Y, and this is B. So the line BB, YY, and RR are connected together. Now the voltage between the two lines is known as line voltage, and voltage across phase of a load, voltage across phase of a load is known as phase voltage. So say this is phi small phase voltage. So between Y and B, say this is phi small y, and say this is phi small. So we have to declare the nomenclatures. So for the balanced supply system, for balanced supply system, let phi ry equal to phi yb equal to phi br equal to phi l dash line voltage. Similarly, phi small r equal to phi small y equal to phi small p equal to phi ph, phase voltage. This is equation 1. Now for the balance load, see already we have studied the definition of the balance load, where magnitudes are equal and displaced from each other by equal angle. So for balance load, I capital R equal to I capital Y equal to I capital V equal to IL line current. And I small r equal to I small y equal to I small b equal to IPH, phase current. Now we have to find out the voltage relation. See, that means in case of delta connected load, what is the voltage relation? Means line voltage, relation between line voltage and phase voltage. If you observe carefully, if you observe the circuit diagram carefully, the voltage across pair of lines is same as that of the respective load, or a pair of lines are connected across the respective load. For example, between R and Y, this is the line voltage phi Ry, but same pair of lines are connected to this load, respective load, and therefore we can say phi Ry equal to phi small, phi Yb, this is phi Yb, but here this is Y and this is B. So voltage across Yb is phi small y, they are equal. So as pair of lines are connected to respective phase of a load, therefore phi Ry equal to phi small, phi Yb equal to phi small, phi Br equal to phi Br equal to phi B. Okay, so from this, phi Ry is nothing but line voltage and phi small r is nothing but phase voltage. So we can write line voltage equal to phase voltage. Therefore, Ph equal to Pl. This is relation number 3. So in this way we have obtained the voltage relation. In case of balanced delta connected load, the line voltage equal to phase voltage, or we can say phase voltage equal to line voltage. Now see the current relation. Current relation. Now for the current relation, applying KCL. To node say R. Obviously we can apply the KCL to node R, Y and B. These are the nodes. So at node R, sum of incoming current equal to sum of outgoing current. So what is the incoming current? I capital R plus incoming is I small b. And what is outgoing? outgoing is IR. And therefore, I capital R equal to IR minus IB. Similarly, we can write I capital Y equal to I small y minus IR, and I capital B equal to IB minus this one IY. So this is equation 4. So in this way, we have apply the KCL to node R, then Y and B. So we got these relations. Now we have to draw the phasor diagram. Sequence is R, Y, B and inductive load. Inductive load indicates that the current is lagging. So we have to draw the structure for this, and we have to consider the 4 phase values, these phase voltages and respective phase currents. So this is phi r, phi small r is nothing but phi ph. Already we have stated. Then r, then it is here phi y, and then here it is phi b. These are the phase voltages. They are equal in magnitude and displaced from each other by 120 degree. Then draw the currents. Currents are lagging. So this is I small r, this angle is phi. Similarly here you can draw this angle is phi. Here this is IY and say this is I. This angle is phi. Now what is the relations? We want the line current. Capital IR is made up of IR minus IB. So where is minus IB? Minus IB will be here. Of the same magnitude, minus IB. And now we have to add them factorially. Parallel to this, we have to draw from this. Parallel to this, draw here. So the resultant is, and this is capital IR, nothing but IL, line current. And note that this angle is, see, angle between IB and minus IB, it is 180 degree. Out of that, angle between IB and IR, 120, so remainder is 60 degree, so this is 30 degree. This is O, say this is A, this is B, and this is C. Here it is 90. Similarly, we can obtain the similar relations for capital IY and capital IB. But one is sufficient to find out the further relations. So here it is. Capital IR equal to OA equal to twice OB. Now from triangle OBC cos 30 equal to, this is base, this is hypotenuse. So OB upon OC. Therefore OB equal to OC cos 30. Therefore I capital R equal to twice OB. It is twice OB. So 2 times OB is nothing but OC into cos 30. Therefore it is 2 multiplied by OC. What is OC? OC is nothing but IR. And cos 30 is root 3 by 2. So this 2 will cancel. and capital IR equal to root 3 I small. The capital IR is nothing but IL equal to root 3. This is nothing but IPH. And therefore, IPH equal to IL upon root 3. So in this way, we have obtained the current relations. So in case of balanced delta connected load, the phase current equal to root 3 upon IL upon root 3. IL upon root 3 or IL equal to root 3 times IPH. So we have obtained these two relations. Now let us obtain the power relation. Power relation. Three-phase power, obvious active power, P equal to 3 into PPH IPH into cos phi. That is 3 into power per phase. Therefore, the P equal to 3. What is phi pH? Phi pH is nothing but phi L. What is IPH? IPH is IL upon root 3 into cos phi. Therefore, P equal to root 3 PL IL cos phi. Unit is watt, bigger in kilowatt, still bigger unit is megawatt. Now similarly we can obtain the reactive power. Capital Q. Already we have studied it in a single phase circuit, that is phi sin phi. So here it is in three phase and therefore Q equal to root 3 PL IL sin phi. The unit is VAR or kVAR or MVAR. Then the last one is the apparent power. Last one is apparent power denoted by S. So S equal to root 3 PL into IL. And this is VA or kVA or MVA. These are the various units. Now what is the relation between these? So S equal to square root of P square plus Q square. Also power factor EF equal to cos phi. Now see the relation between active power and the apparent power. Active power and apparent power. So we can write the value of root 3 PLIL here. So from P equal to S into cos phi. And therefore cos phi equal to P upon S. So in this way, or further, in delta circuit, power in delta circuit equal to 3 times power in star circuit. And line current in delta circuit equal to 3 times line current in star circuit. We are not going to derive this equation, but we will realize after solving few numericals based on this. So power consumed in delta circuit is always 3 times the power consumed in star circuit, provided the circuit parameters remain same and the voltage remains same. And line current in delta circuit is 3 times the line current in star circuit. So in this video lecture we have obtained the current relations, voltage relations, power relations. So in case of balance delta connected load, the line current equal to phase current and the phase voltage equal to line voltage divided by root 3. We'll stop here. Thank you.